Hello and welcome to today's webinar, Build Mobile Backend with AWS Lambda and Amazon API Gateway. Before we begin, let's walk through a few housekeeping items. On your screen, you can see a Q&A pod. Please submit your questions for our presenter and Q&A moderators at any time, and we will address them throughout today's presentation. At the conclusion of today's presentation, there will be 3 poll questions preceding the live Q&A. Today's webinar is being recorded, and we will send you a follow-up email with a URL to the recording once we verify the recording quality, as well as a link to the presentation deck. And again, welcome to today's webinar, Build a Mobile End with AWS Lambda and Amazon API Gateway. Our presenter today is William Negrani. William is a Senior Product Manager for AWS Lambda, a compute service that runs our code in response to events and automatically manages the compute resources for you. Lambda helps developers think about applications in a new way by creating simple event handlers that respond to updates from Amazon S3, DynamoDB, Kinesis, SNS, and other services, as well as directly from the web and mobile apps. William holds an MBA from the University of Michigan and has previous experience across product management, product marketing, and product engineering. Today with us, we also have Stefano Belliani, Senior Product Manager for Amazon API Gateway, and Aaron Cow, Senior Product Marketing Manager for Microservices. Stefano and Aaron Cow will engage with you and answer your questions throughout today's presentation while William presents. William, welcome, and I'll pass the floor to you.
Okay. Thanks, Bowen. Hello and welcome to today's webinar. My name is William Negrani. I'm the Product Manager for AWS Lambda and will be your presenter for today. I have with me here Stefano and Aaron, who will help address your questions over chat throughout the webinar. We'll also do an open Q&A at the end of the webinar, where I will address the frequently asked questions. A quick note on the Q&A, we welcome all types of questions during this webinar, but the Q&A panel may not be able to address roadmap questions or timelines of upcoming features of both of these services. So we do apologize for that in advance. The intention here is to help everybody here understand both of these services in depth. So we'll have to give priority to addressing questions or technical. So with that said, let's jump right into the webinar. We'll be breaking up the webinar into 3 parts today. First, I will start off by a brief overview of what both of these services are and how they can be very useful tools for building mobile backends. Next, we will go through a quick demo of how to set up a mobile backend with an HTTP endpoint using these 2 services on the AWS console. Lastly, we will walk through some best practices, a reference architecture, and code templates for how to set up a production-grade mobile backend application on AWS. So let's start with the API Gateway. Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. With just a few clicks on the management console, you can create an API that acts as a front door for applications to access data, business logic, or functionality to your backend services, such as a workload running on Amazon EC2, code running on AWS Lambda, or any web application. The service takes care of all of the undifferentiated heavy lifting involved in securely and reliably running APIs at scale. API Gateway helps you to manage traffic to your backend systems by allowing you to set throttling rules based on the number of requests per second for each individual HTTP method in your API. In addition, you can set up a cache with customizable keys and time to live in seconds for your API data to avoid hitting the backend service for each request. API Gateway allows you to run multiple versions of the same API simultaneously so that applications can continue to call previous API versions even after the latest one has been published. API Gateway also helps you to manage these multiple release stages for each API version, such as alpha, beta, production, so you can set up various stacks in your production environment and hit each of these independently. Specific stages and versions of an API can be associated with a custom domain name and managed through API Gateway. Stage and version management allow you to easily test these new API versions that enhance or add new functionality to earlier releases, but also ensure backward compatibility as the user continues the transition between these two API stages. Also, to make it easy for you to use these APIs, the API gateway can generate client SDKs for a number of languages, such as JavaScript, iOS, and Android. After your API is deployed, the API gateway provides you with a dashboard to visually monitor calls to your services using Amazon CloudWatch. So you can see performance metrics and information on API calls, data latencies, error rates, etc. as a nice visual dashboard. API Gateway provides you with tools to authorize access to your APIs and control service operation access. So you can use AWS administration and security tools such as AWS Identity and Access Management, or IAM, or Amazon Cognito to authorize access to your APIs. Amazon API Gateway can verify signed API calls on your behalf using the same technology that AWS uses for its own APIs, that is SigWi4. If you are already using OAuth tokens or other authorization mechanisms, API Gateway can forward your OAuth or OpenID Connect headers back to your backend. So your backend can then verify these headers as part of the application code. And lastly, API Gateway helps you to manage the ecosystem of third-party developers accessing your APIs. So you can create API keys on the Amazon API Gateway and then set fine-grained access permissions on each API key, and then distribute these keys to third-party developers so that they can access your APIs. The use of API keys is completely optional and must be enabled on a per method level. So let's talk about the benefits, or why is this a good tool for building mobile backends? As we saw, the Amazon API Gateway handles all the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls, including traffic management, authorization, access control, monitoring, version management, etc. With API Gateway, you pay only for the calls made to your APIs and the data transfer in and out. There is no minimum fees or upfront commitments. This is very useful when you don't know the expected traffic coming to your mobile backend, since you don't have to provision capacity here or you don't have to pay for any unused capacity. You only pay for the actual usage and your performance stays consistently high. With Amazon CloudFront integration, API Gateway allows you to take advantage of a worldwide network of edge locations to provide your users with the lowest possible latency and the best performance for API requests and responses. Also, we talked about the rich set of features like per API metrics dashboards, flexible authentication options, API version management, etc., which allow you to quickly iterate on the API interfaces that you define for mobile backend applications. You can see which APIs your users are calling, when they are calling them. You can also export this data and compare to your device app or your mobile device app metrics for more detailed analysis. You can use authentication option of your choice, including existing Google or Facebook authentication for users to call your API, so that you don't have to ask your app users to remember one more password. And of course, with version management, you can quickly roll back and roll forward the backend app development. But more importantly, you no longer have to make breaking changes to your device apps when you change your code on the backend, since the endpoint stays the same. You're just hitting a different version of your code with the same endpoint. Another very important point is that APIs built on Amazon API Gateway can accept any payloads sent over HTTPS. The typical data formats include JSON, XML, query string parameters, and request headers. You can declare any content type for your API responses and then use transform templates to change back when the backend responds into your desired format. This means that the device app developers no longer need to have to embed the AWS SDK into the client-side application if you don't really want to. They can talk directly to publicly accessible HTTP endpoints, which allow only authenticated users to access the backend application. And of course, lastly, API Gateway integrates with AWS Lambda to allow you to create completely serverless APIs. Now with API Gateway, you can create that REST API that your mobile and web application can use to call as a to call to the publicly accessible AWS services or effectively to your code running on AWS Lambda. Now, Lambda runs your code on highly available compute infrastructure and performs all the heavy lifting and administration of your compute resources. So let's talk about what Lambda is then. AWS Lambda is a compute service that runs your code in response to events and automatically manages the compute infrastructure and resources for you, making it very easy to build applications that respond quickly to new information. Lambda typically runs your code within milliseconds of an event coming in. The service automatically manages the compute capacity for you, spins up the necessary infrastructure, deploys your code, and runs it in response to each event or trigger. Lambda functions are stateless with no affinity to underlying infrastructure, and each event or each trigger is processed individually. This means that Lambda can rapidly launch thousands of copies of the function to run in parallel as needed to scale to the rate of incoming triggers or incoming calls. And performance remains consistently high regardless of the frequency of events or the transactions per seconds coming in. For example, you can trigger an AWS Lambda function to automatically create a thumbnail when an image is uploaded to Amazon S3 or notifications are sent from Amazon SNS, if you want to verify address updates in an Amazon DynamoDB table, or you want to process clickstream data in Amazon Kinesis Stream. Lambda functions can be invoked both directly from external sources, and you can have them invoke synchronously or asynchronously, which makes it easy to build these backend services to perform image analysis, document transformation, indexing. But most importantly, and what I want to talk about today, is that Lambda functions can be triggered by API calls made to the API gateway, which will allow you to quickly build these serverless backends for your mobile application. So let's again talk about the benefits. Lambda allows users to focus on building powerful, dynamic, and modular applications in the cloud, while not distracting their productivity in the undifferentiated heavy lifting of managing infrastructure. Well, since Lambda automatically runs your code on high availability compute infrastructure, and it performs all of the administration of the underlying compute resources, such as server and operating system maintenance, capacity provisioning, auto-scaling, code security, patch deployment, monitoring, logging, etc. All you need to do is write the code. And in terms of code, Lambda supports Python as a new language. Earlier we used to support Node.js or JavaScript and Java, but we recently added Python with more languages to come down the road. Our goal here is to make Lambda a polyglot platform. That's a platform that supports many languages. So there's no new language for you to learn when you're using AWS Lambda. And we have a rich roadmap of languages which we plan to add to the system. The main benefit of using Lambda when building a mobile backend application, of course, is that there is no servers to provision or manage. You don't need to plan for capacity. You no longer need to go through these server patches or server upgrades or software installation. And therefore, you never get paged when your servers are down because everything is managed automatically by the system. Also, AWS Lambda runs your code only when needed with no unnecessary costs. With Lambda, you don't need to build out and maintain a fleet of servers and pay for the time that they sit and wait for their jobs to run. Instead, Lambda charges a low fee per request and for the time that the code runs, making it cost effective to build solutions that scale from not just a few requests a month to thousands or hundreds of thousands of requests per second, which is very typical of a mobile backend when you don't know what your traffic is and one fine day your app kicks off and you have a huge amount of traffic coming to your system. The last benefit here is sub-second metering. AWS overall has changed the traditional IT behavior in this space. Earlier, IT admins used to have to buy hardware servers and then pay for everything upfront. And they also get a 3 to 5 year commitment since they own those hardware servers. AWS changed this drastically to allow customers to pay for infrastructure capacity in chunks of 1 hour. Now, AWS Lambda takes this to the next level, where you pay in increments of 100 milliseconds. This means that if your API call takes 15.7 seconds to completely execute, you only pay for 15.7 seconds. So these three features put together allow you to get an instant 100% utilization on your compute fleet, and you never have to worry about uh, no more paying for idle, no more being under provisioned for when you suddenly kick off and hit peak, no more being over provisioned for off season, and everything matches exactly the rate of incoming events. So you have scaling taken to a whole new level. Now the combination of these two services working together is very powerful. API gateway can act as the front end or the gateway of your mobile backend with a configurable RESTful HTTP endpoint that you can share publicly or even privately as you prefer. Lambda, on the other hand, can act as a compute backend for your service, managing the compute resources for you and executing your custom logic when needed to respond to the API calls. So without managing or setting up an infrastructure, you can build your entire application stack in just minutes, and we will demonstrate that today. And the stack will operate cost effectively at any scale. A few quick details into how the API gateway flow works. The first thing we want to look at is a standard flow of an API call, including all the components of the system. So first, when a request comes in from the client, the mobile app in this case, the request arrives at one of our CloudFront POP locations or the edge locations. It's accepted and routed to the API gateway in the customer's region. So you can specify which region you want your call to be routed to. The API gateway receives this request, checks for a response in the dedicated cache, and if you configure that cache. If there are no cache records available, then it will forward that request to the compute backend for processing. The backend can be a Lambda function, and that's the one that we will demonstrate today. Or it could also be a web service running on Amazon EC2, a container set up on an EC2 container service, or any other publicly accessible web service. Now, once the backend has processed that request and the API call metrics are returned to the user, the metrics are also logged to Amazon CloudWatch so that you can have a dashboard of what's going on later. So today we'll be doing a walkthrough of the simplest mobile backend application that you can think of. Just a simple CRUD backend or a backend to support a create, read, update, and delete type operations using API gateway and Lambda. And then once we build this out, we'll walk through how to make this better and how to move from a simple application to a production grade environment. So let's start with the API gateway that we have created. And this is the REST endpoint or the HTTP endpoint which your applications are going to hit. Whenever this endpoint receives an API call from the client application or the mobile or from the devices, we can configure it to trigger a Lambda function. Now, Lambda can respond to that trigger and can run your custom code to process that request. Since Lambda functions are stateless, we also need a persistent data store to hold that state information. Now here we are going to be using Amazon DynamoDB to store, which is a fully managed NoSQL offering for persisting state and data behind these CRUD operations. So let's see how easy it is to configure this infrastructure on the AWS console. This is the only demo that we are going to be doing today. I do recommend that the audience follow along with me on the AWS console to create a similar setup in your account as a takeaway from this webinar. The resources created in this demo would be covered under the free tier of both of these services. So there's going to be no additional cost for you for clicking along with me other than the DynamoDB, which hopefully if you're still in the free tier should also be covered. So the first step for this is going to be creating the Lambda function. Once you log into the AWS console and select AWS Lambda, or getting started now, or create a Lambda function depending on where you are, you will get to this screen. We have a new approach to creating functions in the Lambda console, what we like to call blueprints. A blueprint is a set of configurations and sample code to quickly get you started for integrating with a specific trigger. Now here I'm going to be selecting the blueprint microservice HTTP endpoint for Python. Now you can find this blueprint just by searching for API in the blueprint screen. We have a similar blueprint called simple mobile backend, but that doesn't integrate directly with API gateway. That allows the users to customize. So I'm going to be picking this one for demonstration purposes since everything is pre-configured. So selecting this blueprint pre-configures some of that mapping and code sample for you. So let's just give it a name and a description for what we want that function to create. Now for creating the function, Lambda gives you three options. The first is to edit code inline, which gives you a WYSIWYG type editor where you can directly start typing the code. Alternatively, you can also upload your code with any additional dependencies or even binaries into a zip file directly onto the Lambda console using the upload a zip file option. Also, you can upload the zip file to Amazon S3 and then provide those S3 object details as the source of your Lambda function, which allows you to integrate your custom deployment tools, which you might have already hooked up with to publish to S3 at the end of it, and Lambda can directly pick up from S3 and deploy as a Lambda function. The Lambda console also provides code templates for different event types or triggers, including Amazon services that Lambda integrates with, as well as direct external invokes. Now here, the blueprint pre-populated the sample code for creating that sample CRUD backend that we talked about. Note that the runtime language here is Python 2.7. That's the example I'm walking through. We have a similar example that you can set up using Node.js. So we welcome users to pick a different language if that's the language of your choice. So let's zoom in into that code and just quickly see what's going on. So instead of doing a full code walkthrough for this tiny code on the screen, let me just show you the highlights. As you can see here, what's happening is that when the Lambda function starts off, it creates an array called operations, which holds all the CRUD operations with DynamoDB. We also have operations like echo and ping pong for testing. And of course, at the end of everything, we have, we pick that operation, we find out what's the operation that's going to be coming in, and we execute that operation with that event payload. And lastly, of course, we use error handling for catching all of these incorrect inputs. So then going back, a few additional configuration changes that you would also need to make in this step listed here. The first configuration on the Lambda console is the selection of the execution role for the Lambda function. This is the permission to allow Lambda to take some actions on your behalf by interacting with other AWS services. For example, the sample Lambda function here needs to read and write from DynamoDB and also publish to CloudWatch logs. The Lambda console provides, again, easy templates for creating these execution roles, or you can select an existing role if you have one. By the way, you also need to select the memory that you want to allocate for your function and the timeout you want to set. We leave these two values to default right now, and we'll come back to fine-tuning these settings. But let's look at role creation for a bit more. So if we select create a new execution role, it'll automatically direct us to the IAM console on AWS, which is a pre-populated policy document. You can change the role name here on the IAM console, or you can expand and edit the policy to add more options. So here's a quick look at the policy document. As you can see here, the policy allows Lambda functions to do two things here. One is to allow Lambda to make changes to CloudWatch logs that you can see at the bottom, and the other is to allow Lambda to read and write from DynamoDB that you see at the top. So if you just click on allow here, it will automatically apply this policy and take you back to the Lambda function that you were creating. Step 3 in here is where you define the configuration for that RESTful HTTP endpoint for the Lambda function. Now behind the scenes, this is actually creating an API deployment on the API gateway service with these configuration details. You can enter the name for the API and it will create a new API for you. Alternatively, you can select an existing API, that's what I have done, and it will create a new resource for you inside that API. Also for this demo, I changed the method from get to post. The default would be get. This will allow me to do something like an old school SQL injection type logic where I post the SQL parameters into the post headers. Now, of course, in this case, you can think of it as no SQL injection. This is just so that we don't have to change the Lambda function code for the purposes of this demo. This is not quite recommended for a production grade environment though. Also in terms of security, I have used AWS IAM. So here we'll be using IAM roles for the API gateway, but you can change this in the drop down to select API keys, or you can select the authentication method of your choice. The last step in here is to just verify the configuration that you have set. If everything looks okay, you can select create function, and most of the configuration will be done for you. The only additional setting I have done outside of this is to create a table in DynamoDB called myTable with the primary hash key set as ID, which is a string value. And that's only to access the DynamoDB table updates. So once I click create function, it will show me that this function has been created and an API gateway endpoint will actually be created here. And you can directly start hitting this API gateway endpoint URL if the client that you have has, in this case, IAM roles configured, or if you have set it to open, you can set it directly even without having any client configured straight from your browser. So let's look at how to test this over here. If you go under actions, you will see a option to say create a test event. Here, if I select mobile backend, it's going to create a sample event which I can throw against this Lambda function. Note here that we are testing only the Lambda function. So what happens is that this is the JSON payload that the Lambda function is going to get as an event object. As you saw in the code, that we are pulling things from the event object. And this is a simple operation. I just want to see if the Lambda function succeeds and everything is set up correctly. If I just hit save and test, it will show me that the execution result succeeded, and it will show me things like how long my function took. As you can see here, it was a very simple function. It just took 0.3 milliseconds. It shows how much memory was actually used. It shows a whole log dump of what was going on. This is just a test to make sure that the Lambda function is working correctly. But let's go over to the API Gateway console and do a full end-to-end test. So if you go to the API Gateway console, you can see here that we had two different options here. So my mobile backend is a method that we just created, so we are going to test that method over here. So again, here if you go in and select operation, it allows you to add a request body to the API Gateway. Note that here what's actually happening is that this gateway function or this method is behind the scenes going to the Lambda function. It's calling the Lambda function, and the response that it gets is actually the response from the Lambda function. So here if I just hit test, what's going to happen is that this is going to trigger that function to respond. As you can see, I got that echo message back here, as well as I'm going to get the details about the response headers, plus a full log stream of what happened. As you can see, the API gateway was initialized, it pushed something to Lambda, and then it got that method from the Lambda function, which is also logging over here. But this is only a simple echo operation. Let's look at a more involved operation over here. And this is where the CRUD application starts kicking in. So here, I will create a complete create application or a create operation over here. So as you see, the operation is create. I'm going to specify the table name as my table. That's a table that I created on DynamoDB. And I'm going to push the item called test01 as ID, which just has a comment called test CRUD operation. And then here when I hit test, the response body is going to be null because I'm not getting any response from the Lambda function. Though I do get the same response headers, the logs, everything of that stays the same. But what has happened behind the scenes, if you go into DynamoDB and look at your table name, you will see that this item is now created inside of your DynamoDB. So from your client application, here we are assuming that this test invoke we are doing from the console, instead of this test invoke hitting that API, you could have your mobile devices, your applications are hitting this API directly, now, whether through IAM credential login or using separate authentication methods. So directly from this mobile application, you are going and storing data in a very backend system all the way through Lambda to API gateway, to the DynamoDB, and that data is getting stored there. Let's look at the reverse operation. So here when you, instead of saying create, if you look at read, the table name stays the same, but the array of the objects becomes a little different. Here it just says key, where ID is test01. If you go and test this operation, what will happen is that it will go back to DynamoDB and fetch that. It will scan the DynamoDB table looking for something which has an ID of test01 as a primary hash key. And here you'll see that it found the hash key as an item which it returns in the response body as comment being what we uploaded a few minutes ago. So with that, as you see, it's very easy to do something, build a mobile backend, or with just a few clicks, we were able to put together a simple mobile backend application which will store the user data in a database table and can retrieve that data through an API call from the client application. Now this pattern is a very well recognized architectural pattern. It's called the multi-tier architecture pattern, and it has been a cornerstone architecture pattern for decades. The multi-tier pattern provides good guidelines for you to follow to ensure properly decoupled and scalable application components that can be separately managed and maintained, often by distinct teams. Multi-tier applications are often used for building such a service-oriented architecture approach for using web services. Now here, what we built was actually a 3-tier architecture, which is a very popular pattern for user-facing applications. The tiers that comprise this architecture include the presentation tier, the logic tier, and the data tier. The presentation tier here represents the components that users interact with directly, such as a web page, a mobile app, or etc. The logic tier here contains the code that is required to translate the user actions at the presentation tier into a functionality or a intelligent response to dictate the application's behavior. And of course, the data tier consists of storage media, such as a database or an object store, cache, a file system, etc., to hold the data that is relevant to this application. The figure on this screen shows the example of a simple 3-tier application, but if you look closely, this is exactly what we built using the CRUD demo that we just went through. In our case, the presentation tier is the mobile app or the client app that goes on all of the user devices. Or in this case, it was the AWS console where we use the test functionality on the API gateway console to call the logic tier. The logic tier is what we built in our walkthrough, using the Amazon API gateway as the front end or the door, and Lambda as the intelligence or as the back end within this logic tier. The data tier called out to Amazon DynamoDB for storing user information. Now, I've also included a link to a white paper that AWS published to elaborate on this architectural pattern and how these two services combined, API gateway and Lambda combined, work as a very effective logic tier. So that's, as I said, was a simple walkthrough and high-level architectural design for getting started. But let's take that one step further. Now, I would like to present what the full-blown architecture would look like if you are going to build a production-grade mobile backend with a lot more functionality than just the create, read, update, delete of key value pairs that I talked about. So let's walk through this complete reference architecture for such a mobile backend. Now I have included a link to the one that we have published on our website, but I will elaborate on the details here, and now I'll break down this into smaller components so you can see what each of these components is doing. The reference architecture here shows an example of a highly available and extremely scalable mobile backend featuring microservices, storage, API endpoints, all of which require zero administration. So let's break down each of the components and give you an idea of the functionality of this setup. And this is much more involved than the simple demo which we put together, but I'd still like to walk through what are the types of things which are possible here. So let's start with the box labeled number 1 on the right. That's Amazon Cognito. Now, mobile users often need to retrieve an identity from Amazon Cognito, which offers a mobile identity management and data synchronization across mobile devices. So once a mobile user has received this identity, the user is granted access to other AWS services. Now, in this case, the user is going to use these credentials from Cognito to log into Amazon API Gateway so that the user doesn't need to remember another password, the user doesn't need the full AWS SDK, and can directly hit that API Gateway endpoint. Number 2 on the far left is Amazon S3. So user-generated media files are stored in Amazon S3 over here, which is a highly available and durable object storage service. So if you have media files which the user is going to be uploading, all of those can be stored to Amazon S3 here. Number 3 right next to it is Amazon CloudFront. So this is used for mobile users this is used so that mobile users can access their uploaded digital assets stored in S3 through a CDN network, which gives it very low latency, and you don't have to hit the backend S3 every time. The objects can be cached at the edge locations for much faster access to mobile users, especially during a read. So number 4, right in the middle, it starts to get into what we talked through earlier. That's API Gateway. So as mobile users send requests to API Gateway to access the application logic and the dynamic data on the backend, API Gateway acts as an entry point for these mobile applications to access the functionality of the code running on AWS Lambda. The API Gateway will also do things like API response caching. It will also manage other authentication, throttling. You can also do limit the number of requests that are going to your backend if you don't really want to brown out, if you want to protect your costs or protect against a DDoS attack. So number 5 in the center is the main Lambda function for this mobile backend. Mobile applications require a highly scalable backend infrastructure to support that variable usage created by mobile users. You might have apps which at the start of the day, if everybody is looking at traffic, then exactly at 8 a.m. you're going to have a huge surge in traffic. And since Lambda runs code in response to requests and automatically manages and scales the underlying resources for you, this Lambda function number 1 provides that synchronous endpoint for users to store and retrieve such unstructured data from Amazon DynamoDB as a backend data store. And you don't have to worry about that scaling or managing infrastructure. Number 6 at the far back is an additional functionality described over here. Lambda function number 2 uses Amazon DynamoDB streams to retrieve changes made by users and creates a searchable document and inserts that into Amazon Cloud Search so that every time you don't have to hit the DynamoDB, especially if you're looking for a group of information or if you're looking for metrics or if you're trying to find search patterns, you don't have to hit the DynamoDB table each time. The streams, DynamoDB streams will go to Lambda function 2. It will collate all of the information and store it as a searchable document in Cloud Search. And then number 7 on the left is Lambda function 3, which then provides that synchronous interface for users to search data into Cloud Search. And Cloud Search manages and scales a search solution for the mobile backend devices to search through. And as you can see, all of those are fronted by these same API gateway, and you can have different methods going to different Lambda functions. including Lambda function number 4 on the right, which provides that asynchronous endpoint for mobile users to communicate with other mobile applications. For example, you might want the function format to change. You might want to have a communication request and send a push notification to some other users over SNS. So that Lambda function 4 allows you to create those push notifications to SNS. So as you can see that this is a very involved architecture, but instead of saying that you need to build something on your own, lastly, as I promised, here's the sample code for setting up this entire reference architecture above with just a few clicks. You can download this entire repository from the GitHub URL provided here. The code on this repository contains 2 CloudFormation templates. The first one sets up the static configuration services of the reference architecture that I just showed, such as Amazon S3 for the media file repository, Amazon CloudFront for the content distribution network, and Amazon DynamoDB to store the user data. The second CloudFormation template contains the script to create the Lambda functions once you upload them to S3, as well as all of the IAM roles and policies needed to run this setup. So setting up the whole script once you download the code is just 5 clicks. With click 1, you deploy the basic setup using the first CloudFormation template that I talked about. In click 2, you create the cloud search domain manually from the AWS console. And you need to do that today. Soon, hope this should be automatable too. With the third click, you go and update the environment variables. Now, once you have all of the endpoints that you created in your existing setup, you copy those endpoints and update those as environment variables into your Lambda function code. The README in the code template shows exactly how to do this. So once you upload all of your code from this mobile backend to S3, the fourth click would be to run the second CloudFormation template, which picks up this code from S3 and deploys it as a Lambda function. And it uses all of the IAM roles to make sure that you have the right credentials to set everything up. Lastly, one more manual step, which also should be automatable soon, is to hook up the DynamoDB table as an event source for the DynamoDB streams to go to that Lambda function number 3 for generating that searchable metrics. And that's it. Just with these few clicks, you now have a highly available, highly reliable, high performance, and then of course, extremely low cost mobile backend setup for your client application. This is only the reference architecture we have built. Of course, you are more than welcome to download and edit this code and customize it for your application. Now, you might want to change to store custom media. You might want to change what user data is getting stored. You might not want the cloud search functionality, and you can simply remove those components from your CloudFormation scripts. So we absolutely recommend everybody to give this a try. We have 3 next steps for you from here. As you can see, I have labeled all of them number 1. The first is to create and test your first API. As you saw, with just a few clicks in the AWS Management Console, you can create an API that acts as a front door for applications, for your mobile applications, for your mobile users to access data, business logic, or functionality to your backend services. Also recommend to create and test your first Lambda function. Now, with AWS Lambda, there are no new languages or tools or frameworks to learn. We have quite a few blueprints, so you can very quickly get started. You can even bring in third-party libraries or native libraries, application binaries. Note that both of these services offer offer up to 1 million requests per month, and as part of the free tier. So if you're just trying to build something, you're going to get no charges in your account. So absolutely encourage you to go and set something up here. And of course, select Lambda as a backend for your APIs. You can use the sample code and the setup instructions that we provided here in this webinar to quickly create your mobile backend application using API Gateway and Lambda. And you can of course choose between the demo application that we created and then create everything from there, or you can use the reference architecture and create a production grade environment with lots of functionality built in. So that's all we had from the presentation. Thank you so much for listening in. Hope this was very valuable for you. We recommend that you visit the API Gateway or Lambda forums and let us know if you have any further questions. We are always happy to help. We'll take a quick 2-minute break here, after which I'll return and address some of the questions from the most frequently asked questions in the Q&A panel. Thank you. Okay, welcome back. I'll go through some of the common questions that you have over here. I see a lot of questions on new programming languages. When will you support PHP, or when will you support other languages in here? I see Go, I see .NET. All of these languages are definitely on our roadmap, and we are taking votes right now. So all of your questions coming in here are going to count as votes, and we'll prioritize our roadmap for these questions accordingly. I have questions around, can I create and upload my own blueprints? So unfortunately, we don't have that option today. We definitely will be adding that functionality soon. So thanks for that +1. We definitely would like users to be able to add blueprints too. But in the meanwhile, we recommend that if you have any functions which you really want to contribute, you can always use GitHub, and you can, with a few clicks, you can copy code from GitHub or from Amazon S3 buckets into Lambda functions. So you can use those effectively as a code repository for pushing functions to Lambda. I have a few questions on how to avoid the warm-up time of JVM and Lambda. Now, so just a quick background for folks who aren't aware of this. Now, when Lambda function starts up for the first time, we use containers behind the scenes, so the JVM boot up may take a couple of seconds. If you have latency requirements which are higher than, which need to be faster than that couple of seconds, and you can't afford this even once in a while, then what you could do is you could have a scheduled function which goes and hits the Lambda function once in a while, just to keep it warm. Also note that at scale, this entire thing should go away. What happens behind the scenes is that Lambda, once you have a request come in, it doesn't kill the container, so that the JVM effectively stays warm. So at scale, we have seen more than 99% of requests are hitting a warm container. So you don't really have to worry once you're hitting scale. This is only during your very first invoke that you will see this latency. This is not something that will happen at scale. I have a question about licensing requirements. So what happens to the licenses, the server licenses that you bring in when you move your code to Lambda? So Lambda function, effectively, we are running Amazon Linux behind the scenes. So anything which you're bringing on should be compatible with Amazon Linux. That's number one. And any licensing requirements is something which you'd need to manage externally. So if you're bringing licensed code to Lambda functions, then Lambda is going to scale out behind the scenes. So you'll need to make sure that you limit your scale out functionality so that you don't have to pay for too many licenses here. What you could do is you could always try to create copies of this licensing so that you talk to your software vendors. And if you have specific questions, always comment on the forums, and we'll be happy to work with the vendors, work with your vendors for you. I have a question on how Lambda functions can be tested on local machines. The code that the runtimes that we are using on Lambda are all open runtimes. It's standard stock Python 2.7. It's standard Java 8. It's stock Node. So the entire functionality that you are running can be exactly simulated on your local environment. The only thing which you would be missing is the hookup from the API gateway, because that hookup is created only on the Lambda function. What you could do is, API gateway offers a option for creating a service proxy. So you could boot up an EC2 instance and run that Lambda function, run your test code on that instance, and then use Amazon API gateway to create an AWS service proxy onto that EC2 instance. So this way you are testing that end-to-end functionality using the service proxy option. And once you are ready, you just move everything over to Lambda function and then let Lambda do the infrastructure management and the auto scaling and scale out on your behalf. I have a question on how do we pre-test or unit test before deploying. I'd say that that's a pretty similar way in which you could do it. The AWS console offers a lot of options for unit testing it. As we saw, we were able to test the Lambda function individually on the Lambda console. You can go to the API gateway console and test the end-to-end functionality. And of course, you can, as you are building this, as you are building your Lambda functions, we have lots of plugins to integrate a deployment process. For example, we have a Jenkins plugin, so you can you can create the functions locally, test them locally, and then just use Jenkins to publish to Lambda. We also have different IDE plugins. So if you're developing in Eclipse, you can test locally in Eclipse, and then you can test individual modules. You can create breakpoints, and once your function is ready, you can use the Eclipse plugin to push that Lambda function up to the Lambda console. I have a question on, can Lambda function execute on multiple cores? So I'd interpret that as two different questions. So one is, can we use threading or multiprocessing on Lambda functions? Can we fork out Lambda functions to execute multiple processes? Yes, absolutely. Whatever programming languages, the standard ways of forking processes and creating threads, you can use all of those on Lambda. You can create up to 1,024 handles, whether they are thread handles or fork handles within the Lambda function. The other way of thinking of that is, what's the infrastructure, what's the hardware behind the scenes, and does that hardware have multiple CPU cores per function invoked? So you can think of that hardware as equivalent of an M3 type of instance behind the scenes, where it's a general purpose family. So while you are configuring only the memory setting or the RAM setting on the Lambda function, we allocate CPU resources, network IO resources proportional to that memory. So the more the memory you configure, you're going to get more CPU power available. So at the max CPU power, you're going to get that ratio. The ratio stays the same, and that's equivalent to the general purpose family. So if you're setting up 1.5 GB, then that's when you get that full core of processing in the back end. I'm looking at the other questions, and I see see a question which says, can one Lambda function handle multiple API calls? The way it works is that every API call is going to be an individual Lambda function. You could start batching your requests if you use an intermediate service between API gateway and Lambda. For example, if you're using API gateway and all of the requests coming from API gateway are pushing through to Kinesis, which is our stream management service. So the user immediately gets back a 200 response saying, acknowledge, we have accepted the create that you sent in. And then Lambda could read off of the Kinesis stream, and there it can batch up to 10,000 requests at a time. So you can have 10,000 of your APIs, everything pushed to Kinesis, and then Lambda pick up all 10,000 in just one big Lambda function and push all 10,000 to your backend database, for example, together. So you could optimize your create, so you can map your put API method to push to a Kinesis, while your get API methods goes directly to Lambda. So you can map it in that way to effectively get lots of functions coming into the same Lambda, lots of API calls coming into the same Lambda function. So we have a question, can Lambda be used for binary or streaming uploads? So for example, we want to customers to upload images straight from an API call. So today we do not have that option. Today everything needs to be packaged into a XML or a JSON format. So even if you're uploading a binary image, the client application, your app, needs to be smart enough to wrap that the stream or the binary stream or your JPEG stream into a XML format. All you need to do is just add a image/image tag at the start and end of that binary stream, and then that will be recognized as a JSON payload, which can go through API gateway, and API gateway can pass that JSON along to Lambda, and then Lambda can get in its memory as the event object. But definitely, thank you for that feedback. We are working on making that a bit easier for you. There's a question on, is it possible to maintain a pool of connections to DynamoDB between several Lambda calls? So as I said, the way it works behind the scenes is we use containers, we use Linux containers for each individual Lambda function. Every function becomes a Linux container. When we have a first invoke coming in from API gateway, we spin up that container. But after that API execution is done, we do not kill those containers. We keep all of those containers alive for the next few minutes so that the next API call can be processed on that same Linux container. So what you can do is you can create that connection to DynamoDB on the first API call, and then that connection will persist as long as that container persists. So what will happen is that you don't have a new connection being spun up and spun down for every API call. You just have a few connections spun up at the first API calls, which persist for the lifetime of that container. So as long as you have ongoing traffic coming in, that same connections will persist to your downstream connections, downstream databases. And only when your traffic subsides will those connections automatically terminate. Okay, we are at the top of the hour, so I want to respect everybody's time here. Thank you so much for listening in to today's webinar. We hope it was really helpful for you. As usual, if any questions were left unanswered, please post them on either the API Gateway forum or the Amazon AWS Lambda forums, and we'd be happy to address them there for you. Okay, thank you.